So I had recorded this earlier during Zoom, but my computer ended up rebooting, so I'm going to go ahead and redo this recording. So hopefully it comes out pretty good. So this is the study guide for your test that's for tomorrow. So when we're looking at the first question, number one, it says which table represents a proportional relationship? Remember, when you're finding whether or not you have a proportional relationship, the first thing you have to do is you have to find the constant of proportionality every single time. And that's always in the format of y over x, y divided by x. So your tables here are always set up as xy in that order. So think of this as four separate problems. We're going to want to find to see which ones have a constant of proportionality. So if we're looking at this first one, don't do anything with that 0, 0 because that's not going to help you. You're looking at the first set of non-zero numbers. So you've got 2 and 4. So to figure out my constant of proportionality here to see if this one has one, you would do y over x, which is 4 over 2, which does simplify to 2. Then you've got 9 over 3, which simplifies to 3. Now I'm going to stop there. Because of the fact that these two numbers don't match, automatically tells you that this is not a proportional relationship. Now we're going to do the same thing with this next one. So if I'm doing 6 over 2, I get 3. 9 over 3, I get 3. And then 12 over 4, I get 3. So the fact that you have 3's here tells us that this is most definitely a proportional relationship. Okay, now over here this question says which table, so there's only one correct answer on this one, but I do want to go through the other two to model for you like why they would not be proportional. So for this one, if you're doing 6 over 2, you do get 3, but for this one, 3 over 3 gives you 1. Again, the fact that you already found that they don't match, they are automatically not proportional. On this one, you get 6. 15 over 3 gives you 5, and I'm going to stop there because the fact that they don't match tells me they are not proportional. One thing that I do notice is a lot of you just kind of look and stare at the tables, and you do no writing off to the side of them to determine if they're proportional or not. So when you're working like on a computer screen or online, you want to make sure that you've got a piece of paper there and jotting this information down so you can keep track of everything. All right, question number 2. So number 2 says the graph shows the C cost in dollars of W pounds of peanuts, a proportional relationship. Select all the true statements. So on one of these select alls, you guys, you know that there possibly could be only one right answer, but it's also possible that every single one of these could be a correct answer. So the first thing that I needed to do is determine what C was and what W was. And you'll notice that I kind of have some stuff circled here. C represents the cost. So on my graph, you'll see where they put C right here. That's your cost. So I went ahead and wrote that, which is in terms of money. All right. And then the other value, the W, which is what they labeled this line here, was your pounds in peanuts. So that's the amount of pounds that you have of peanuts, the amount of peanuts that you have. So they gave you one ordered pair on this. They gave you the ordered pair 7, 17.5. It's always in the format of X, Y. So if I were to go ahead and set this up as a table, because for me, honestly, it's the easiest thing for me to be able to see this information. So this is what I get. Now keep in mind, they didn't really use XY here, but normally this would be your X column and this would be your Y column. So your X column is your peanuts, like the weight of peanuts. So I guess I'll leave the X there, but I'll just put peanuts here so I know that that's what they're talking about there, which they're using the W for. And then my Y column is your cost, so that's your money. Okay, so that's going to be with the letter C. So I do need to label it to make sure that I know what we're doing here. Now that I have this ordered pair written here like this, you know the first thing I'm going to do, guys, is find the constant of proportionality every single time because that's going to help me answer this question. So to find the constant of proportionality, you're doing 17.5 divided by 7. And I get 2.5. So what that 2.5 means is that when X is 1, when the number here is 1, your answer for the other column is going to be 2.5. Now we are talking about money, so technically it's $2.50, but I'll leave it like this for now, okay? So that means 1 pound of peanuts costs $2.50 each. Now this is saying that 2.5 pounds of peanuts will cost $1. Well, that's not the case, because if that was the case, they're saying that the 1 would be here. So in order to figure out what this number would be here, when I make my dollars 1, you would have to do 1 divided by 2.5. And you end up getting 0.4. So that does not work. What that means is 4/10 of a pound of peanuts will cost you $1. And that doesn't meet this, this proportionality here. Okay. Now the next one says 1 pound of peanuts. Here's my 1 pound of peanuts. Costs $2.50. And sure enough, we know that that is a true statement. 5 pounds of peanuts cost $12.50. Well, we have to figure that out. If I have 5 pounds of peanuts and each pound costs $2.50, I end up getting 12.5, which is the same thing as $12.50. So that is correct. The next one says 9 pounds of peanuts. So I'm going to do the same thing. 9 times 2.5 for $2.50. I get $22.50. You'll notice here 9 pounds of peanuts tells you that it costs $19.50. That one doesn't work. And then we've got one more. The point 410 is on the graph of the proportional relationship. All right, guys, so if I have 410, and if it's saying if it's on the graph, that means it's going to have the same exact constant of proportionality. So let's test this guy out. If my first number is 4 and the other one is 10, and I figure out, well, what's the constant of proportionality for this? 10 divided by 4, because it's y over x, you get 2.5. Well, guess what? It matches every single other one. So E is a correct answer for this problem. The other way that you could have done this is you could have said, well, if my x is 4 and I multiply by 2.5, do I get 10? And of course you do. Okay. So number 3 says Kieran walked at a constant speed. He walked 1 mile in 15 minutes. Which of these equations represents the distance d in miles that Kieran walks in t minutes? Well, first of all, the fact that it's a constant speed, and we're talking about equations, we've mentioned several times that your equations absolutely have to always be in the format of y equals kx. Always, always, always. There's 2 choices here you can automatically eliminate. Choice A and B, because this says plus 14 and this one is minus 14. So if whatever I do to the T and the D, yeah, that can stay proportional, but once I start adding things in there, it doesn't work out. So now if you're having left to guess because you're confused or you get stuck or you just have a brain freeze, then at least if you realize, hey, it's got to be y equals kx, you're now choosing between C and D. All right. Now here's the tricky thing about this one, is making sure that you have your, and again, it helps me with setting things up as a ratio table, but you want to make sure that you have your things set up properly. So on this one here, since it's y equals kx, k is going to be my constant of proportionality. It's either going to be a 15 or a 1 over 15, so don't let this trick you just quite yet. Because what ends up happening is when we're talking about distances, we're talking about how long it takes someone to walk. So this person takes 15 minutes to walk 1 mile. We typically do it in kind of their speed as time per minute, or per mile, excuse me. I didn't mean to write minute there, mile. So we know that this person in 15 minutes will walk 1 mile. It's the same thing as saying 1 mile in 15 minutes, but it does make a little bit of a difference with which of these 2 equations is going to be the correct one. So it says that they want you to determine the distance. So we want the distance is going to be essentially the portion that we walk for every minute. So T represents the minutes. So now if I'm doing this, remember, if you're setting it up in the format of y or of xy like this, so here your x is your T value, your y is your D value. Now take these numbers and plug them into the correct spot. Your 1 mile is your distance. That's got to go here. Your 15 minutes is your time. That's got to go there. So now when you're figuring out your constant of proportionality, which will give us that k value, you're doing y over x. You're doing d divided by t, and that's how you get your 1/15, and that's why choice D is the correct choice for that one there. Number 4, the 2 lines represent the distance over time that two cars are traveling. Which car is traveling faster? Explain how you know. Okay, so what I like to do here, guys, and I'm going to make this just a little bit higher here. I like to just sort of, I call it put in pretend numbers. So let's say for time and hours, I put a little tick mark here, and I say that this right here is going to represent 1 hour. Okay, so I'm going to very lightly kind of extend that line there. So what that means is in 1 hour, car A is going to travel this distance, which is wherever this is right here. But in 1 hour, car B will have traveled this distance here. Well, keep in mind on a number line, because this is just a vertical number line, if I were to sit there and start at 0, which you always do, the first number that you're going to hit is going to be a smaller number. So let's say this represents the number 5, and then the next one's going to be the number 10. So car A in 1 hour travels maybe 5 miles, but car B in 1 hour is traveling further up on the number line, could potentially be traveling 10 hours. So ultimately, car B is faster. And it says explain how you know. Remember when we were talking about lines and which one is steeper? So car B is faster because, first of all, it's going to travel further in the same amount of time as A's, all right, so further, but it's also steeper. Its graph is steeper. That means it's more upright. So the more upright that this line is, the faster it's increasing, meaning the further that they're traveling. So for example, if you look at my pencil, this is how steep line car B is. Well, car A, excuse me. Car B is a little bit more upright, okay? And I could even make something even more steeper. So the further upright, like vertical, that a line is, the steeper it is, the quicker that it's increasing, okay? The quicker that the height is going up. Number 5, the table shows the weights of bananas at a grocery store. Complete the table so there is a proportional relationship between the number of bananas and their weight. All right, you hear this word proportional relationship? Guess what we have to do? Find the constant of proportionality. Every time you're doing y divided by x. So on this guy right here, all right, we're doing 1.6 divided by 5. That gives you 0.32. That would be if I had 1 pound of bananas, guys, or I'm sorry, if I had 1 banana, it would weigh 0.3 pounds. That's what this constant of proportionality is telling me. So in order to figure out my missing numbers here, I'm going to take my 3 and multiply by the 0.32. This is 0.96. And then for this guy, 12 times 0.32 gives me 3.84. So those would be the missing numbers on my table. Question number 6. So number 6 says the equation S equals 50 plus 45W represents the savings S. So S, you guys, is the word savings. After W weeks, so weeks represents the letter W, or W represents weeks, working and depositing money into a savings account at the bank. Okay, it says determine whether there is a proportional relationship between S and W. Explain or show your reasoning. Well, here it is, proportional relationship and an equation. So I think I've basically have said this numerous times. In order for an equation to be set up as a proportional relationship, it has to be in the format of y equals kx. Nothing can be happening to this other than the constant of proportionality being multiplied by x. That's it. You can't have anything else added or subtracted to it. Here's where the problem lies in this guy right here. It's got a plus 50. Yes, it's at the beginning of it, but automatically, guys, the fact that you see a plus sign and then another number attached to this tells you automatically that this is not proportional. Now this question says explain or show your reasoning. So if you were to explain your reasoning, you could simply just tell me that it is not in the format of y equals kx. But I also want to show you guys like how you can prove the fact that it's not proportional. So if you remember here, so over here, I'm going to go ahead and put my W and my S. So remember, this is your X, this is your Y. All right. So what this equation is telling me is that I should be saving money. So let's say after 1 week, so if I have 1 week that I'm working, when I plug in 1 where W is, it'll pop out my S value. So think of it as like input, output. So on this guy here, I'm going to start with my equation. if I replace W with the number 1 right here, that's through multiplication. All right, so all I did is just replace that there. Now I'm going to go ahead and add this together. So ultimately what you're doing is you're doing 50 plus 45 because 45 times 1 is 45. So that means your savings after 1 week will be $95. Now you got to do it one more time to test it out. So let's say this time I'm going to change my W to 2 for 2 weeks. All right, so I'm going to go ahead and start with my equation again. So this time I'm replacing my W with the number 2. Well, I've got to do this first. 45 times 2 gives me 90. And I'm going to go ahead and add 50 to it. So 50 plus 90 ends up giving me 140. Now I have enough information to figure out if this is a proportional relationship, because what you're going to do is you're going to do, guess what? Your y divided by x. Well, this one I already know is going to be 95 because 95 divided by 1 gives you 95. So we're going to test the second one. We just need those 2 points. 140, oops, clear that. 140 divided by 2 gives us 70. So right there, I just proved using numbers that this is not a proportional relationship. All right, our last one. So number 7 says a recipe for a smoothie calls for 5 cups of strawberries for every 2 cups of bananas. The line represents the relationship between the amount of strawberries and the amount of bananas needed to make a smoothie according to this recipe. The point 1, 2.5 is on the line. All right, so we know that this is proportional because it's a straight line, it goes through the origin, and plus, and it doesn't tell us, does it tell us up here? I don't think it tells us it's proportional, but remember, goes through the origin, straight line, it's proportional. So letter A says label the axes appropriately. That means, you guys, we're talking about 2 different things here. We're talking about bananas and strawberries. I have to determine which axis is going to represent my bananas and which axis is going to represent my strawberries. So that's what A is telling you to do. All right. So over here, this is what I'm going to write down here. So we've got the ratio of strawberries to bananas. So when my strawberry number is 5, my banana number is 1. So, it's 2, not 1, my bad. Okay. So if you notice this ordered pair, it's the ordered pair 1, 2.5. So what basically they're doing here is they're essentially kind of simplifying it, figuring out how much for 1. So remember we talked about when your x value is 1, this is your x value, then your constant of proportionality would be wherever it meets that line, which is basically your y value. Well, if I sit there and I can't turn this into a 1. I mean, technically I can. If I do, I'm not going to end up getting the 2.5 here. So essentially what it is they're taking half of each of these numbers. So if I make my banana number the number 1, what you're doing is you're multiplying it by 1/2. You're going to do the same thing to your strawberry number. You're going to multiply that by 1/2. And you do end up getting 5 over 2 is the same thing as 2.5 or 2.5. But keep in mind, the way that I have this written is in the format of x, y. X has to be the number 1. So we're just going to flip-flop this, all right? So instead of bananas being our second one, it's going to be our first one. And I'm just going to put straw here for strawberries. So the 1 for bananas goes here. The 2.5 for strawberries goes there. Because now that makes sense, because I can get the 1 to 2.5. We're just keeping the ratio the same. We just flip-flop them. And remember, the banana number is the 2 that turned into a 1. So you're keeping those numbers with it. So going on here, if bananas is the 1, this right here axis is my banana axis. And the other one is my strawberry. So we did letter A. B, write an equation, again, should be in the format of y equals kx, that represents this proportional relationship between the strawberries and bananas. And then it says indicate the meaning of each variable. That's the first thing I did. So I'm going to use B for banana, S for strawberry. So a lot of times what I've shown you in class is I like to start out with my y equals kx because it just makes it easier for my brain. All right, to think of it in that format. Now I'm going to replace that y and that x number with the b and the s. So if I look over here, my X number is my banana number. So this is where I would basically replace my X with a B for banana. My Y is my strawberry. And then my constant of proportionality is my K. Guess what? That's 2.5. That's where the Y value is when your X is 1. So for this guy, I'm just replacing it with a 2.5. I'm going to rewrite that bigger. And this is what your equation is for that one. And letter C says, explain the meaning of the point 1, 2.5 in terms of this situation. All right, you guys, the situation is the fact that we're making a smoothie with strawberries and bananas. So the 1 represents the number of bananas. The 2.5 represents the number of strawberries in cups. So this meaning right here means that for every 1 cup, I got the 1 from right here, of bananas, you need 2.5 cups, got that from there, of strawberries for a smoothie recipe. Okay, so you're just trying to attach it to the story of, hey, we're making a smoothie. All right, kiddos, hopefully that will help for those of you that need to see that review again, and we will see you guys back in class tomorrow.